Hello everyone and welcome to episode 3 of our C++ mastery course. Now, if you may remember from the last episode, I accidentally skipped over Booleans, and Booleans are very important. So in this video, we are going to cover Booleans that I accidentally skipped over. Now, every decision your computer makes comes down to one thing: yes or no, on or off, true or false. And that's exactly what Booleans are and what they represent in programming. They are the backbone of all logic in programming. So without any further ado, let's get into it. Now, if we look at the screen right over here, let me just zoom in for you guys. I have made two Booleans. One is rainy and the other one is sunny. And is rainy I have set to true, and is sunny I have set to false. Now, compared to other programming languages, the true and false is lowercase and not uppercase. This will not compile, as you can see. And if we look down here, I've decided to print out is raining and is raining and is sunny. Sorry. Now, you may expect that is raining will print as true and is sunny will print as false. But actually, if we build this over here, and you see I run it, we get 1 and 0. So is raining is 1 and is sunny is 0. And that's because Booleans are just stored as integer values of 1s and 0s in C++. 1 being true and 0 being false. This does mean that Booleans are in fact 8 bits. So you're only using one of those bits to really store this. So it's a bit inefficient, but we won't get into that right now and how you can, make it more efficient. We're just going over how Booleans work in general. So, okay, 1 is true, 0 is false. But let's say now you want to actually print out the value of these Booleans. Well, you can use std bool alpha, right? Let's end the line, I believe. Now, if we build, what error do we have here? Oh, I built with the wrong thing. Okay, there we build. Now you can see it prints as true and false. So C++ added this little console bool alpha thing so that we can actually print them, and we don't have to do an if check to print them. It's just a little bit nicer, okay? But as we said, true is 1 and 0 is false. But that does mean that since the Booleans are just integers under the hood, we can actually save is raining as any positive value and it will evaluate to true, whereas is sunny only 0 evaluates to false, and this will compile just fine. We run it and we print it. As you can see, it prints 1 and 0. So this is an interesting fact where, as I mentioned, any positive value is true for Booleans, and any positive value is true and 0 is then false. Okay. Now, as you can see on the screen, what I have is two integers, a and b, a being 10 and b being 20, and we have a bunch of comparison operators. And these are just evaluates to Booleans under the hood. So for this one, we're checking if a and b is logically equivalent, that is the two equals, and we can save that into a bool is equal, right? Of course, a and b is not the same. This is 10 and 20, and this actually looks at the what is stored at those memory addresses and checks if those two are equivalent, right? So again, remember, if you're comparing two Booleans, for example, if a and b were Booleans, and a was, let's say, 1, and then I'm just going to write it out. Let's say we have two Booleans, C and D. This is a Boolean, and this is a Boolean. C is 1, and this is like this, right? They both are true, and now we're comparing the address of those two. So this, in some cases, in some compilers, in some versions of C++, could actually evaluate to false, because it will compare the memory addresses of these two, which is obviously not the same, even though they both hold true values. I believe in modern C++, Boolean already handles this nicely, and it should be true because they're both true, okay? But this is just an interesting thing to know where Booleans can have positive values. Be careful of this. It may bite you in some versions of C++ or using some compilers, okay? So equivalent, we have not equivalent or not equal. Obviously these two are not equal, so this will evaluate to true. We have A less than B, A is less than B, so this is true. A greater than B, no, this evaluates to false. A less than equal to B, true. And A greater than equal to B, false, okay? And then if you print all of these out, you will see that we get, since we're using the bool alpha, we get the actual values right down over here, okay? Now, one thing to notice is a common mistake that people sometimes do is they will say something like if A equals 2, right? And now this will compile, this is valid C++, but now you forgot the comparison operator, the double equals, checking if they're equivalent. You're just saying if A equals 2. So what you're doing is you're actually setting A equal to 2, and since 2 is positive, this if check will always run, okay? This is always true. So funny enough, people, some people, older generation, they like to do something like this, where they swap them around. I don't like this, but it does avoid this problem, where as you can see, this won't compile now, unless we add the comparison operator, okay? Because we can't set 2 equal to A. So that is one thing to take note of. And then also one thing that I want to mention is be careful to not compare, let's say, one logically equivalent to something like this, right? Be careful to not compare floats like we do over here, because if you remember from our data type video on floating point numbers, this could be stored with an error, right? So this could be, instead of being 3.0, it could be like 2.999, you know what I mean? There could be some error, and then it's not exactly equal to this. So comparing floats is very sketchy, and you should favor doing what we did in our other data type video, where we convert these to integers. We just multiply them by 10, let's say, something like that, or some sort of scaling factor. You know, if it's like this, then we multiply everything by 10, it becomes 21. You get the idea, right? This becomes 10, and then we're converting the floats to integer values, and we can actually compare them properly, okay? So that's one thing to take note of. Now, if you see on the screen, I have two variables, has ticket and has ID, and can center takes has ticket, logical and has ID. Now this uses, if you're not familiar with logic, I recommend reading it up, but this is just a basic logical and. So has ticket is true, has ID is false, so this will evaluate to false if you print it out, right? Do not confuse it with this. This is the bitwise and, which we will probably get into another video. You can also do the logical or, which is like this. Now this will evaluate true because at least one of them is true, all right? These are also the logical operators in C++. We then also have the not operator, which is just the exclamation mark right in the beginning. So whatever ticket has ticket is, it's just the opposite of it. So has ticket is true, we not it, so can center will now be false. All right, simple as that. It's the reverse of it. We don't have a ticket right now. That's kind of the logic that we're working with, okay? You can also combine logical operators, like you look at age, has license, is sober, car has insurance, and they have a bunch of different stuff. So can this person drive? If age is greater than or equal to 16 and they have their license and they're sober and their car has insurance, then they can drive. As you can see, their car doesn't have insurance, so this will evaluate to false and they can't drive, even though they're sober, they have their license, and they're over 16. All right. Then in C++, there is an order of precedence for these logical operators, and this is the highest order to the lowest order. It goes from the not and to the or. So if we look at this result right over here, this is true or false and false. This will be evaluated first the false and false, and then the true or and the result of false and false, as you can see with these brackets. Okay, it will basically, insert the brackets like that, which will be false. True or false will just be true. If we look at this, not has the highest priority, so it will not the true to be false. It will OR it with the false, and then we'll get false. And then when in doubt, you should use parentheses. So when you're working with different logical operators like this, just use parentheses. Don't confuse other developers into remembering this order or confusing yourself into remembering this order. Just use brackets. It makes it a lot easier, okay? Now, here we have a bit of an interesting one. If you're not too familiar with functions, don't worry about it. But for those more advanced viewers who are a bit ahead, let's look at something a little bit more advanced. So we have check A, and check A was called and returned false. Check B was called and returned true. Now we want a result. So we AND check A, the function call, which is false, with check B, which is true. And since this is an AND, we know that both need to be true, and C++ is clever, right? So once we call check A and evaluates to false, it won't even call this function for check B. It won't waste its time. It won't waste that execution time on doing that. So just as a quick showcase here, if I run this, you'll see that the only thing that gets printed is check A was called, and the result is false. Check B is never ever called. This is a bit of an interesting one, and not a lot of developers know this. But yeah, if you want some extra efficiencies to squeeze out that little bit of performance, you should put the function that is most likely to evaluate false first in your logical checks, because if that is false, the other checks will not run. Now, I wanted to go over a bitmask and how we can more efficiently store Booleans. For example, like I said, it's stored as 8 bits and we're really only using one of those bits for the Boolean value. So realistically, you could store 8 Booleans for the same size as one Boolean. I wanted to go over that, but I think I'm going to save that for a separate video all on its own. For now, this is more than enough information on Booleans, and I hope you found this useful and I hope you learned something from it. Thank you for watching. If you enjoyed the video, please like, subscribe, and follow for more, as we are going to continue going on the series and go through absolutely everything in C++. If you have any questions, put them in the description and I'll answer. They don't have to be related to C++ or this video. Just ask anything in general and I will answer it as soon as I can. Thank you for watching.